Let's talk about diffraction gratings. So a diffraction grating is basically a series of many slits. Okay, basically this thing that you see over here. And they could be a lot of slits. And so typically you may even describe this as the number of lines per unit length. So for example, this could be 800 lines per mm. Okay, that would be a nice typical grating. So first thing that we need to do, we need to figure out what D is. D is the average slit separation. And so we are looking at this average distance here between the slits. Okay, so for example, D will simply be, in this case, the unit length. Okay, so that's, of course, 1 millimeter, all right, divided by 800, all right? So that's how you find D. Now, your diffraction pattern is going to look something like this, okay? What you will notice is that there is a very large central maximum, and this is because you think of all the waves from all these slits converging over there to form a very large maximum, but there will also be other peaks as you move to either side of the central maximum, and we call these the nth order maxima. So you have, in this case, the first order maxima, the second order maxima, third, fourth, fifth, so on and so forth. Notice also that the distances between these maxima are not uniform. In fact, they get larger and larger as we move up the order numbers. So, how do we characterize this entire thing? Well, for any given maximum, apart from the central, I can always calculate a certain angle that's subtended like this. Let's call this theta 1. Right? So this is the angle subtended between the horizontal line to the central maximum and to the point where the nth order maximum forms. Right? And so d sine theta equals to n lambda. This is your formula that describes diffraction gratings, this beautiful thing over here. Okay, remember, I'm just going to add something here. You can think of it as d sine theta n. So for example, I could substitute the wavelength of the wave inside here. Of course, this is quite self-explanatory. Okay, and then as long as this value of n here and this value of n tally, this formula will work. So for example, if I wanted to find theta 1, I would sub in n equals to 1. Okay, and then if I solve this equation, I will get this angle here, right? If, for example, I subbed in n equals to 2, then you would be getting this angle here that's subtended from the horizontal line to the second order maximum, the point where the second order maximum forms, so on and so forth.